So here we have to show that the height of the cylinder of maximum volume that can be inscribed in a sphere, inscribed. So the cylinder of maximum volume, the height of the cylinder of maximum volume that can be inscribed in a sphere of radius r. So the sphere of radius r, okay, this is r, okay, this is also r. Let's say the radius is x. So here it is told that if the volume of the cylinder, volume of the inscribed cylinder is maximum, then the height of the cylinder that should be equal to 2r by root 3, where r is the radius of the sphere. R is the radius of the sphere. Radius of the sphere. And also find the maximum volume. And the maximum volume of the inscribed cylinder also we need to find. Inscribed cylinder, also we have to find that. And this statement we have to prove. Prove this. We have to prove this also. So now, here we can see that the radius is r and this is x. Suppose the radius of the cylinder is x, then the uh, the uh, the height of the cylinder is h, and the radius of the cylinder is x, suppose. So diameter, the diameter of the cylinder will be 2x. Now, therefore, here one right angle triangle has been formed where this is the diameter of the sphere, which is 2r. Diameter of the sphere is 2r, and the height of the cylinder is h, and the diameter of the cylinder, that is 2x. So now, therefore, we can say that 2x whole square plus h square, that is equal to 2r whole square by using the Pythagoras theorem. So therefore, we can say that 4x square plus h square, that is equal to 4r square. So therefore, from here we can say 4x square, that is equal to 4r square minus h square. So therefore, x square will be equal to r square minus h square by 4. So this, where x is the radius of the sphere we have considered, where x is suppose the radius of the sphere. X is x is the radius of the cylinder, of the base of the cylinder. X is the radius of the base of the cylinder. So now, therefore, the volume of the cylinder, volume of the inscribed cylinder, that will be equal to pi x square into h, pi x square into h. So that will be pi into r square minus h square by 4 into h. So that will be pi r square h minus pi h cube by 4. So this is the volume of the cylinder, which is a function of h, v of h. So we need to find the maximum volume of the cylinder. Maximum volume of the cylinder that we have to find. So now, therefore, v of h is maximum. V of h is maximum when v dash h, that is equal to 0, and v double dash h, that is greater than, that is less than 0. Then only h will be the point of local maxima of the function v of h. H will be the point of local maxima of the function v of h. Okay. So here h is the variable actually. H, which is the height of the cylinder we have assumed. Height of the inscribed cylinder. Height of the inscribed cylinder. That should be h that we have taken as h. So we have to find h in terms of r actually. So first we have to find the we have to take the first derivative of the function v, and that should be equated to 0 to find the value of h at which v dash is 0. So therefore v dash h, that will be equal to d by dh of pi r square h, d by dh of pi r square h minus pi h cube by 4. So that will be equal to pi r square minus 3 pi h square by 4. 3 pi h square by 4. That should be equal to 0. So therefore, say that 3 pi h square by 4, that should be equal to pi r square. Means pi will cancel. So h square will be equal to 4r square by 3. So therefore, h will be equal to plus or minus 2r by root 3. But negative, the height cannot be negative. So therefore, only the positive value we have to take. So h should be equal to 2r by 3. And so v dash 4r by 2r by 3 is 2r by root 3 is 0. And we have to find then v double dash h. That will be equal to d by dh of pi r square minus 3 pi h square by 4, which is v dash h. So that will be 0 minus 2 3 are 6, 6 pi h by 4. So that will be 2 2s are 4, 2 3 are 6. So this is minus 3 pi by 2 h. Now therefore v double dash 2r by root 3. That is equal to minus 3 pi by 2 into 2r by root 3. So 2 is cancelling. So this is minus root 3 by r, which is less than 0, obviously, since the radius of the sphere, that is always greater than 0. And v dash 2r by root 3, that is equal to 0. So we can say that h equal to 2r by root 3 is the point of local maxima, of the function v of h. So therefore the maximum volume, of the inscribed cylinder, maximum volume of the cylinder inscribed in the sphere, of radius r, will be obtained if the height of the cylinder is, and if the height of the cylinder is h equal to 2r by root 3. h equal to 2r by root 3. And then we have to find the maximum volume also. So therefore the maximum volume of the cylinder, that will be equal to v of 2r by root 3. So that is, actually this is pi r square h. So that is pi r square into 2r by pi r, sorry. This will be pi r square into 2r by root 3 minus this will be pi by 4 into h cube. So that will be 2r by root 3 whole cube. 2r by root 3 whole cube. 2r by root 3 whole cube. So that will be equal to 2 pi r cube by root 3. 2 pi r cube by root 3 minus, this will be 8 r cube by 3 root 3 into pi by 4. So 4 2s are 8. So this will be, so 2 pi r cube. 2 pi r cube I can take as common. By root 3 also I can take as common. So this is 1 minus 1 by 3. So this is 1 minus 1 by 3, that is 2 by 3. So that is 2 by 3 into 2 pi r cube by root 3. So this is 4 pi r cube by 3 root 3. So therefore, the required maximum volume of the inscribed cylinder is the maximum volume of the inscribed cylinder is 4 pi r cube by 3 root 3. So this is the final answer. Hope you have understood the concepts. Thank you.